after the first experiment that I attempted to calculate the sun's diameter in degrees, I thought of another one, which is this one. So I took a sheet of paper and I went on my patio. This is one of my railings, or the vertical post on my railing, and I marked on the piece of paper where the sun's shadow is cast. And you can see that it's grading from a full shadow to full illumination. There's a bit of a gradient here, and at the time I eyeballed it where I thought the full sun was lighting the paper, but you can kind of see in this photo that it's more here. At least that's what it looks like here at the moment. I'll keep playing with the brightness levels and you'll see where exactly it lines up. So unfortunately, I moved the piece of paper between the first one and the other ones. So each one of these is 30 seconds apart. And you can see that as time went on, the sun moved and so did the shadow. So this would be the kind of like the penumbra, and this would be the umbra right here. So we need to calculate the number of pixels of the penumbra. So let's just duplicate this layer and I'll play around with this one. So color levels. And come on. There we go. So here, if I adjust these colors, these levels right here, you'll be able to see. So that's going to be that one. And I'm going to pick a color that is very much not in the image. I'll pick this nice blue one. And make sure my main layer is selected. Probably go, that's probably going to be about the right size, I guess. And then draw a line more or less where the shadow meets the full sun. Now if I do that, you can see where this is the full sun's illumination and this is the gradient. Unfortunately, it didn't pick the blue color. So now we'll do the same thing with the other one. So I'll duplicate the layer again, make this one 50%. Okay, make this one 50% after much fiddling. And then I'll do something similar. I'll go colors, color levels, and this time I'll pick this one. And what that does is it basically pushes all of these that are above this threshold to white, and it pushes all of these that are below this threshold to that color. So now we can see what the other one is. And I'll click OK. And do something similar, but this time I'll make sure I've got the right colors. OK. And why pick the right color. Whatever. Okay, so now I'll come over to here. Actually, I'll pick a nice reddish color. How about this one? And I'll do something similar. I'll grab this guy here, click it here, and kind of go like that. So this should be the umbra, that should be the penumbra, and that should be the full illumination from the sun. And now we need to figure out how far it moves in a minute. So unfortunately, because I moved this, I'll have to go and grab it from one of these other ones. And I'll do something similar here. I'll maybe take this one, copy this one onto this one, new layer, layer, anchor the layer. Okay, so now we've got our two layers, and now I just need to look at this hard edge on each one. So I'll take this one, I'll duplicate this layer, color levels, pick the same level range that I had before. And we can see that there's a nice hard edge right there. Make sure that I'm back on this layer. Come back over to here, try this again. Turn this off. We should be able to see our pencil mark, our red line. Yeah. Now I'll pick this one and duplicate this layer, although I probably don't need to do that for this one. So that is basically going to be the same. So this should be the same as this one. Okay, so now I am going to do something similar, color levels. Oops, pick this guy. Okay, come back over to here, got my color, and go from here to there. So this is, let's say this is 0. This is going to be 30, 90, 120. So in 2 minutes, it traveled this far. So now let's figure out what that is. So if I'll zoom in and grab my measure, and around the 2000 pixel mark, we've got (366) pixels, maybe 365, 364. So let's say it's 364. And in here, we have 350. So pixels per second. So if I go 364 pixels divided by 120 equals 3.03 pixels per second. Add that to my memory. So now I take 350 and I divide that by that. I get 115 seconds. I figured it took 115 seconds for the sun to arc across the sky so that from the start of the penumbra to the start of the umbra was 115 seconds. Now we know that the sun arcs across the sky 15 degrees in 1 hour. So to calculate the angle, we take 115 and then we divide that by 3,600. And that is how many hours it took for the sun to go from here to here. And now if we multiply that by 15 degrees, we get 0.4807 degrees. So that is the second method that I thought of to calculate the sun's diameter in degrees. I just realized there was a little bit of a mistake on my part. I went back and looked at the different measurements, and you can kind of see where the shadow lies. The umbra is a little bit farther to the right than I had originally placed on the line. The original line was right here, but you can kind of see where the umbra is. It's just a little bit farther to the right, and when I do that, it turns out it's 396. So if I take 396 and divide that by my value, then divide that by 3600 and multiply that by 15, I actually get 0.543 degrees. So it really kind of depends how accurate you want to be, given the fuzzy nature of where the umbra ends and the penumbra starts, and of course where the penumbra ends as well. So you've got the no shadow, you've got the penumbra, and then you've got the umbra. So it really depends where exactly you can get those two edges will determine the sun's diameter in degrees.